So we're talking about how Big IP uh, implemented the VXLAN for ARP request or no request. So to expand on that, I wanted to talk about how VXLAN works on the Linux. So here is a slide I found on the SlideShare, and this slide is from a Red Hat solution architect. So he talked about how VXLAN works on Linux. Let's see the slide. So VXLAN basics. The objective of VXLAN is to creating a virtual layer 2 network over physical layer 3 network. And so he gave a diagram example with 3 data centers and with physical layer 3 network. And then this is the logical layer 2 network. And so here is how the VXLAN encapsulates a layer 2 packet inside a layer 3 packet, which by the way is the UDP packet. So for example, if a container or a virtual machine send a packet from Tokyo data center to Osaka data center, how it knows the destination IP address or container or virtual machine is in Osaka. So this is the encapsulation in L3. So the fundamental problem of layer 3 over layer 2 over layer 3 network is how to find the correct location of packet destination. So yeah, so how did you know that the destination is in Osaka when this packet arrived here? So how do you know the dest address YY is in Osaka? So we need an ARP, right? ARP resolution on layer to layer. VXLAN switches needed to emulate the ARP resolution mechanism. So basically, we needed to, from this virtual machine or pod, we needed to send ARP request to find what is the MAC address for this IP address. So this ARP request, ARP reply, then add it to the MAC table in the switch. Then the last step, send the layer 2 packet. So this is the encapsulation. Outer layer 2 header. Outer L3 header. And then the payload is the original packet. Additional feature for L2 over L3. So packet encapsulation is not enough for layer 2 over layer 3. VXLAN switches needed to implement the following features. ARP resolution. Needed to reply to ARP requests from local servers without broadcasting the ARP packet. Destination search. Needed to find the destination location corresponding to the destination map. So the VXLAN endpoint providing these features is referred as VTAP. So the VTAP has above additional features. One is for ARP resolution, another is for destination search. So how to implement it? This is the key point I want to mention here. This one, and this one. So you can implement the VTAP for 3 variations. The first one, exchange MAC IP information using L3 multicasting among switches. So yeah. The second one is use SDN controller as a central MAC IP database. The third one is use local agent and a virtual VXLAN switch running on Linux servers. So this the third one in blue color character is the one that the FNANO is how FNANO works in this design. So basically, in each node, you run a local FNANO agent or daemon set, and then that work with the VXLAN implementation in the Linux kernel. Yeah, let's go into that. So here, talk about OpenStack. We can skip that since we want to talk about Kubernetes FNANO container technology. So VTAP implementation with FNANO. Here, talk about FNANO is the open source tool to create overlay network for Docker containers used with Kubernetes. It uses Linux kernel native VXLAN devices for packet encapsulation. FNANO daemon dynamically populates the forwarding database and the ARP table according to kernel request with L2, L3 means notification mechanism. So by the way, so here is a new term L2, L3 means notification. So this implementation is originally called Dove extensions, and it has the kernel patches here. Yeah, again, so in each node, it runs a FNANO daemon set, and that FNANO daemon set is supposed to set up a VTAP interface on each node. Yeah, so if you run the IP command to show the FNANO interface, you will see more detail about what VXLAN ID, what is the local IP, and what flag the VTAP interface, tunnel interface has, and the destination port. So here it has the proxy flag and the L2 means flag. turn on. VTAP features are implemented with a userland agent via L2, L3 means notification mechanism. So the notification is sent via let link. L3 means the kernel asks the agent to populate the local ARP table when necessary, instead of broadcasting the ARP request packet. L2 means the kernel asks the agent to populate FDB when necessary. So this L2, L3 means the kernel will notify the user agent, which is the Flannel daemon running on each node, that is responsible for to populate the ARP table and the FDB table. So where the Flannel agent get those information from? It will get it from the Kubernetes cluster. Yeah, that's basically what his slides talk about. And so now I can show you. This is the actual kernel patch to implement the Dove extension to how to notify the user from kernel to notify the user agent for L2 or L3 means. So here is the three main goals from this patch. And then you can look at the patch code. So there is a VXLAN IP miss, which is a L3 miss. As you see here, it will notify with a message type get a label. So this is L2 miss, and then it will do a notification from kernel to user space. Again, the same message type. By the way, this is a let link message type. So this is the ARP reduce, which is which is the VTAP host. The VTAP interface, the tunnel interface, will do the proxy, the ARP and ARP request, and create ARP reply for the remote pod. Here is the ARP create to create the ARP reply. Another route short circuit to skip route lookup. As you can see here, is if the VTAP or tunnel interface, VXLAN interface has the proxy flag on, then do the ARP proxy. And if it has the route short circuit flag on, and do the route short circuit. Here are those flags: L2 means, L3 means, route short circuit, ARP proxy. Yeah. And so, but if we look at our, say if I'm on my master node, I have the VXLAN interface here. So this is my VXLAN interface set up by the Flino agent. But you can see here, I don't have proxy flag, no L2, L3 miss flag here. So something is different, right? And then if we go to Flino code, so this is the Flino VXLAN.go file, which is to create the Flino link VXLAN link interface, and you can read through here. It will talk about some history, design history. So the first, it will have those things L2, L3 miss flag on the VXLAN interface, the Flino interface. So the second version of Flino VXLAN removed the L3 miss. The latest version of VXLAN backend removed the need for L2 miss. That's why you don't see the L2, L3 miss flag on the Flino.1 interface. I think we talked about these three before, but we skipped this L2, L3 miss. So here it is, why the L2, L3 miss not showing up there. And by the way, register the network, and this is the function that actually created the Flino VXLAN interface. If we go into that function, as you can see here, the link attributes, it has learning, false, no learning. So no learning. Oops. So Flino interface, no learning, right? And so no L2, L3 miss. Here is that actually set up the link, the Flino VXLAN interface link. So this explains why on Linux, when you ping a remote pod or container or virtual machine, you don't see a ARP request for that remote pod, because everything is automatically populated by the Flino agent. So what else I want to talk about? Yeah, again, so variation of VTAP implementation. Use local agent and a virtual VXLAN switch running on the Linux servers. So this is more efficient way to do it. I think so here is a more a Chinese version of someone explained step by step to set up the VXLAN network on the Linux, and so it actually explained the different